Hi guys, thank you for watching my previous video. So today we are looking at a new chapter called Further Coordinate Geometry. So this chapter is right after the previous chapter, Coordinate Geometry. So let's take a look at this question. So we are asked to sketch the graphs of y equals to square root x over 2 and y equals to 8x to the power minus 3 over 2. So over here, you see 4 types of graphs. So to sketch the graph, so you must first know the basic graphs. So let me do some manipulation. So y equals to square root x over 2 is actually y equals to half x to the power half. So this shows us that this graph should look like our graph 1. So let's draw this out. Y equals to half x to the power of half. So let me draw the two axes. So this is the graph of y equals to half x to the power of half. And by the way, these basic graphs you have to memorize all on the spot. You can use your calculator to sketch it out. Now let's find out how should the y equals to 8 times x to the power minus 3 over 2 look like. So it should look like graph 3. So what I'm going to do is draw the y equals to 8 times x to the power minus 3 over 2 in the same graph. And it should look like graph 3. So the question is asking you to sketch, so you just have to sketch it out. You don't have to be really exact, but you don't sketch it such that it is so out of the reasonable range. Okay, so I have drawn y equals to 8 times x to the power minus 3 over 2. So as you can see, the point of intersection, and by the way, I don't have enough space over there, so let me do it here. So now we are asked to find the coordinates of P, which is the point of intersection of these two graphs. So what we need to do, so we need to solve these simultaneous equations. So we have these two equations. So what we need to do, we need to solve these two simultaneous equations. So we equate the two of them, and you should park your x one side and park your non-x the other side. And after that, your result should be x to the power of half over x to the power of minus 3 over 2 equals to 16. Therefore, you should get x to the power of 2 equals to 16, and x is equal to plus minus 4. Remember, when you square root 16, you get plus n minus 4, and we have to reject minus 4 because from the graph we know that x is on the right side, therefore it's positive. So when x is equal to 4, let's find out your y, and your y is equal to 1. Just sub in x equals to 4 into one of the equations. Therefore the coordinates of P 4, 1. Now let's find the equation of the perpendicular bisector of OP, where O is the origin. So in order to do this kind of question, please try to sketch out how it should look like. If not, you will not understand it clearly. Don't try to put things in your head. Try to put it down on the paper. So I have sketched it out, the line of OP, and I have also labeled the coordinates. So we are asked to find the equation of the perpendicular bisector of OP. So I have also drawn the perpendicular bisector of OP. So let's find out the gradient of OP first, because this gradient of OP will help us find the gradient of the perpendicular bisector. So the gradient m of OP is 1/4. Therefore, the gradient of the perpendicular bisector of OP, we call it PB of OP. Short form, PB, perpendicular bisector of OP, is -1 divided by 1/4, and you should get -4. Okay, so the next step is we need to find one set of x and y coordinates. Then we can create the equation of the perpendicular bisector for OP. And the points that lie on OP and also lie on this perpendicular bisector of OP is the midpoint of OP. Therefore, find the midpoint of OP. So 4 plus 0 divided by 2, comma 1 plus 0 divided by 2, and you should get 2, comma half. So this is the midpoint of OP, which lies on OP and the perpendicular bisector of OP. So we need to sub in this set of x and y coordinate into the equation y equals to mx plus c. Therefore, you can find out your c. So your c is equal to 8.5, if you can see it. It hangs, and it should recover fast enough. So your c is equal to 8.5. So therefore, your equation is y equals to -4x plus 8.5. So the equation of perpendicular bisector. Now let's come to the new question. So it says a circle has center -1 and 1. So I've drawn it out. That passes through 2, 5. So I have also drawn this out. And by the way, you should try to sketch it out yourself if the question never provide you. It's important you sketch it out so that you see it, you visualize it. So the standard form for the equation of circle looks something like that on the right. I'm not sure if it will be provided. If not, you have to memorize it. So let's find out the R. R is the radius, while AB is the center. So we have the center, -1 and 1. Our job is to find R. So how to find R, the radius? So if you have original point O and you have the point P, so the R is the radius, which is the length of OP. So therefore, if you remember the formula for the length of a straight line, it should be x1 minus x2. I should not write x to the power 1, I should write x1. So very important, x1 should look like that. So x1 minus x2 bracket square plus y1 minus y2 bracket square. So just sub in the values. And you should get 2 plus 1 bracket square plus 4 square, and then square root the whole thing. And you should get 5. So therefore, you have your center and you have your R. What you need to do, just sub in your center and your R into the standard equation. Therefore, the equation of the circle is bracket x minus -1, which is x plus 1. Or before that, let me write down this standard equation. And in this case, sub in -1 into A, sub in 1 into b, you should get x plus 1 bracket square plus y minus 1 bracket square equals to 5 square, which is 25. Okay, so that is the equation of the circle. It is a new concept, but you just have to find the values of a and b and r and then substitute into the equation. Now we are asked to determine if 3 lies on the circumference of the circle. So it is easy, right? So if the equation of the circle is given or found out just now, what we need to do, we just need to sub in this 3 and 3 into the equation of the circle and see if the equation is valid or not. If 3 and 3 lies on the circumference of the circle, the above equation, after sub in 3 and 3, it should be valid. Okay? So let me sub it in to see if it's valid. So my x is 3, my y is 3, so sub it in, I get 3 plus 1 bracket square minus 3 minus 1 bracket square. Let's see if the left hand side is equal to right hand side. My right hand side should be 5 square. Therefore I put a question mark there. So I get 16 plus 4 on the left. Therefore 20 is not equal to 25. So this shows that this point 3 and 3 does not lie on the circumference of the circle. So this is how you test if a point lies on the circumference of the circle. It's a new concept again, but it is not hard. So I hope you are clear about how to prove if a point lies on the circumference of the circle, given the equation of the circle. Now let's come to the next question. This question again is about the equation of circle and is given x squared plus y squared plus 8x minus 10y plus 21 equals to 0. And first, let's take a look at the general form of this equation of circle first. This is the second general form of the equation of a circle. So therefore, if you compare term by term, you should see 2g equals to 8, 2f equals to minus 10, and your c is 21. And what it says minus g minus f is the center. So what we need to do, find out what's g, find out what's f. So g equals to 4, f equals to minus 5. And we are asked to find the radius and the coordinate of center of the circle. So after we found all these g, f, c, and then you just need to sub into the general equation. Center, bracket minus g, comma minus f, so you get the center minus 4, comma 5. Radius, square root g squared plus f squared minus c. So which is 16 plus 25 minus 2. And let's take out your calculator and punch your calculator. You should get square root 18. Oh no, it should not be 18. It should be 20. So let me erase it and put in 20. And therefore you get 2 square root 5. So I have answered part 1. Now comes to part 2. So we are asked to show that the line x minus 2y plus 4 equals 0 is a tangent to the circle. So the key concept here is if an equation is tangent to the circle, this means there is one solution. If there is one solution, the discriminant is equals to 0. So let me refresh some of the key concepts of discriminants. So over here you have one root, therefore it's an equal root, therefore discriminant is equal to 0. So what you need to do, you just have to rearrange your x minus 2y plus 4 equals to 0 and then sub in your x equals to 2y minus 4 into the equation of a circle. okay? Because we need to show the line is a tangent to the circle. So sub in x equals 2y minus 4 into your equation 1. It's pretty complicated, but don't worry. You just have to do it step by step. And I have to warn you, Amaths is always very complicated. That's why you have to have a very solid foundation in Amaths. So I have already subbed in my x equals 2y minus 4 into equation 1. My job now is to open the brackets. My job now is to open the brackets. And you should get 4y squared minus 16y plus 16 plus y squared minus your 16y minus 32 minus 10y plus 21 equals to 0. And what you need to do, combine similar terms. Minus 16y plus 16y cancel each other. 4y squared plus y squared, you get 5y squared. Plus 16 minus 32 plus 21, you get plus, right? You get plus 5. And minus 10y, you are left with. So the whole equation is simplified into y squared minus 10y plus 5 equals to 0. And you can take out the common factor 5, and you get y squared minus 2y plus 1 equals to 0. And let's continue to find the discriminant. Discriminant formula b squared minus 4ac. So let's sub in your a, your b, and your c. And you should get bracket minus 2 to the power of 2 minus 4 times 1 times 1. And your discriminant should be equal to 0 because tangent to the circle, that means there is one solution only. So let's see if we can get our d equals to 0. Yes, so it's valid. Our discriminant is equal to 0. Therefore, we can show the line x minus 2y plus 4 equals 0 is a tangent to the circle. So you just have to show that discriminant equals to 0. And we have shown that. And now, let's go ahead and find the coordinates of point of contact of the tangent and the circle. It's easy, right? So we just have to solve these simultaneous equations. And we have already done a lot. So if you solve the equation, you get y equals to 1, x equals to minus 2. Therefore, the coordinates of the point of contact is minus 2, 1. Okay? Very easy. Next, we have come to the next question. So this chapter has a lot of new concepts. Okay? So once again, the general form or the general equation is on the right. And we have the equation of C1 given. So let's compare the terms to find out what is our G, what is our F, what's our C. So minus 8 is equals to 2G. Minus 84 is our C, and 2F is equal to 0. So therefore our G is equals to minus 4, our F equals to 0, and our C is equal to minus 84. So with this, we can find the center and the radius of the C1. Because basically, we just have to sub in our G, our F, and our C. And therefore, the center is 4, 0. And now, let's find out the radius. So sub in G, F, C into this equation. So if you have done a lot of practice, this kind of question is very mechanical. So therefore your R equals to 10. So I have found the center and the radius of C1. And now we are asked to find the coordinates of B. So what information we have to find the coordinates of B? So we are told that the tangent to C1 at the point B has a gradient of minus 4 over 3. So let's make use of this information. And by the way, B lies on the circumference of circle C1. So we already have one equation, and therefore we need another equation so that we can solve the simultaneous equations. So let's find out another equation which involves our B. So we are told that the gradient at the point B is minus 4 over 3. So with this gradient, so we know that the gradient of AB is negative 1 divided by this minus 4 over 3, because the tangent has a gradient of minus 4 over 3, which is m equals to minus 4 over 3, and AB is perpendicular to this tangent. Therefore, you get the gradient of AB equals to minus 1 divided by minus 4 over 3, and you get 3/4 for the gradient of AB. Okay, so over there it should be minus 4 over 3. Never mind, I will edit it later. So the equation of AB is y equals to mx plus c. We have the m already, so now we need to use one set of xy coordinates. And we know that the coordinates of A is 4, 0, because the center of C1 is A. So therefore, we sub in this set of xy coordinates into y equals to mx plus c, so that we can find our c. So therefore, you get 0 equals to 3/4 times 4 plus c. So your c equals to minus 3. Therefore, we get the equation of AB equals to y equals to 3/4 x plus minus 3. So we have two equations now. And let's make use of these two equations. Which two? Equation of AB and equation of C1. Why? Because point B is the intersection point of the circle C1 and the line AB. So if B is the intersection point, what does that mean? It means we have to solve simultaneous equations. Which two equations? Equation of the circle C1 and equation of the line AB. Okay? So now, let me sub in y equals to 3/4 x minus 3 into the equation of C1. So we are given the equation of C1. So let me copy it down first. So the equation of C1 is given as x squared plus y squared minus 8x minus 84 equals to 0. So let's label equation 1 and equation 2 and sub equation 1 into our equation 2. So you get x squared minus it's not minus, so x squared plus bracket 3/4 x minus 3 to the power of 2 minus 8x minus 84 equals to 0. So what you need to do, you need to expand or open the bracket, and if you go ahead and simplify, you should get x squared minus 8x minus 48 equals to 0. And this is a quadratic equation, use table method, you should get x minus 12 bracket times x plus 4 bracket equals to 0. And therefore, you should get x equals to 12 or x equals to minus 4. And for x equals to minus 4, we should reject this value because clearly b is on the right side of your y-axis. So it should be positive. So we only take the positive value of x, which is 12, and sub this x equals to 12 into equation 1. And you should get y equals to 3/4 times 12 is 9. So 9 minus 3 equals to 6. Therefore, the coordinates of B is 12, 6. Now we are asked to find the equation of C2. So let's take a look at the circle C2. So in order to find the equation of it, we need to find the center point, and we also need to find the radius. So the center point of C2 is the midpoint of A and B, right? Because AB is actually the diameter of your circle C2. So the midpoint of AB is easy. The midpoint of AB is equals to 4 plus 12 over 2, comma, 0 plus 6 over 2. And you get the midpoint of AB equals to 8, 3. And let me correct some of the minor mistake there first. So once you find the center of this circle C2, the next job is to find the radius of circle C2. So since the diameter is AB, right? So we just need to divide AB, or the length of AB, by 2. And that's the radius of this circle C2. So therefore radius of C2 is equals to half times 10. 10 is the radius of the circle C1, which is also the length of AB. Therefore half times 10, we get 5. So now I am trying to label it in the circle of C2 so that it appears clearer to you. So I have found the center and I found the radius of C2. So just put these values into the equation, the general equation shown there. So you should get x minus 8 bracket square plus y minus 3 bracket square equals to 25. That is the equation. So we have come to the end, and I hope you have enjoyed it. Goodbye, see you again.